So our topic was on how early life stress can affect the brain, and we decided to focus specifically on how it can affect the amygdala and connectivity. So my article is titled Early Life Stress, Frontoamygdala Connectivity, and Biological Aging in Adolescence, and it's a longitudinal investigation by Miller et al. In 2020. So just a quick overview. Exposure to ELS in early childhood and early adolescence, which can be family violence, poverty, or emotional abuse, has significant effects on brain development. Early life stress may accelerate frontoamygdala development related to socio-emotional processing, serving as a potential source of resilience. And this study took a sample of young adolescents and examined the relationship between ELS, frontoamygdala circuitry when viewing emotional faces, cellular aging, which was measured by telomere shortening, and pubertal tempo. The connections between the amygdala and the prefrontal cortex are very sensitive to a wide range of experiences of ELS during the different developmental stages, and ELS is associated with the earlier development of inverse or negative frontoamygdala connectivity and has generally been associated with better outcomes such as effective emotion regulation, lower levels of internalizing symptoms compared to adolescents that have not experienced ELS. And then one aspect that this study focuses on specifically is how the ELS can affect pubertal tempo, which is the pace at which adolescents mature, and accelerated pubertal tempo has been associated with stress and other mental health problems. So this picture on the right shows the regions of interest, and on the left in the yellow is the basolateral amygdala, or the BLA, and the red is the central medial amygdala, or the CMA, and then on the right is the ventromedial prefrontal cortex, or VMPFC, and that's highlighted in red. So the researchers conducted this study with three goals. The first, they assessed whether and how ELS was associated with frontoamygdala connectivity. Previous hypotheses predicted that higher ELS will be associated with more negative frontoamygdala connectivity. The second set of analyses evaluated two different hypotheses on whether and how frontoamygdala connectivity is associated with changes in telomere length in puberty. And finally, the stress acceleration hypothesis, which is the previous hypothesis, suggests that negative frontoamygdala connectivity results in adaptive outcomes in the context of mere exposure to the adversity. The researchers also examined whether the severity of the ELS resulted in associations between frontoamygdala connectivity and telomere shortening and pubertal tempo. So there were 214 participants, 121 were girls, 93 were boys. They were ranging from 9 to 13 years old, and they were gathered from the local community using flyers, media, and online advertisements. Participants were excluded for a number of reasons, and since girls experienced puberty earlier than boys, they were matched on their self-reported pubertal stage rather than chronological age, which in result meant that girls were younger than boys in the mean sample. ELS in this study was operationalized as stressful events occurring up to adolescence, and these adolescents completed interviews assessing exposure to 30 different types of stressful experiences using a version of the traumatic events screening inventory for children, and then their responses were turned into code by a panel of trained raters that did not see the adolescents' reactions. So the procedure of this study was to have participants passively view pictures of faces of men and women expressing 6 different emotions, which were anger, disgust, fear, happy, neutral, and sad, and they viewed 8 different pictures. And then the researchers administered an MRI task to scan the neural activation in response to this stimuli. And then finally, the researchers conducted correlation and regression analyses to examine if there were associations between ELS, amygdala activation and connectivity, telomere shortening, and pubertal tempo, and then any outliers were identified by using box plots. So the results of this study showed that participants who experienced higher levels of ELS had greater activation in the right CMA, or the central medial amygdala, and more negative right and left CMA VMPFC connectivity, or the ventral medial prefrontal cortex. And participants that experienced ELS showed increased negative connectivity These associations, combined with previous research, show that connectivity is associated with telomere shortening and pubertal tempo differently at low and high levels of ELS severity. Frontal amygdala connectivity during this socio-emotional processing appears to affect cellular aging and pubertal development. And then negative connectivity between the MPFC and the amygdala has indicated more effective emotional regulation. And then positive connectivity between these regions is more typical in childhood and reflects less mature circuitry. So this is what adolescents who don't experience ELS will show. And then this graph on the right shows the central medial amygdala VMPFC connectivity and right central medial amygdala activation associated with early life stress. And you can see the negative correlations and the positive for those that did not experience ELS. The researchers also observed heightened amygdala activation in the right CMA in adolescents who were exposed to higher ELS, and this study suggests that negative frontoamygdala connectivity is an adaptation to ELS, which actually provides protection against accelerated cellular aging and pubertal development, and has also been linked to resilience against early anxiety and more efficient emotion regulation. And frontoamygdala connectivity appears to be unrelated to biological aging in adolescents who are exposed to less ELS. So in conclusion, ELS is associated with stronger reactivity to socio-emotional stimuli in the right CMA, which is in the amygdala. And negative frontoamygdala connectivity was associated with slower telomere shortening and slower pubertal tempo, which is just slower pubertal development. And this was significantly stronger in adolescents who had experienced higher ELS. And then the limitations of this study was that the measure of ELS was based on self-report. So this graph on the right shows the interactions between severity of early life stress and the magnitude of the amygdala connectivity. So basically, overall, in simple terms, participants that reported greater ELS showed more negative frontoamygdala connectivity, which results in slower telomere shortening, which in turn results in slower pubertal development. And then participants that also experience greater ELS show more early and efficient emotional regulation and have increased resilience against early anxiety compared to adolescents that have not experienced ELS that showed positive frontoamygdala connectivity and have less mature circuitry.